this is part B of laboratory number 5, gas loss. Okay, we're using the same vernier measurement unit and the same vernier pressure sensor, although this time we've used the accessories in the kit to connect the pressure sensor to a 125 milliliter Erlenmeyer flask. Okay, and I've put the 2-hole stopper in the top. One of the holes goes to the pressure sensor via this tube. The other is sealed off with a small valve, and make sure that valve is closed. Now, in doing this, we have trapped a volume of air in there. Okay, so that volume is going to stay the same, and we're going to look at what is the effect of changing the temperature on that pressure. So right now we're reading atmospheric pressure because we set it up at atmospheric pressure. So what you're going to do is use a thermometer to measure the temperature in the room, and then you're going to write that temperature down here, room temperature, what is the temperature, and then you're going to write that pressure down, which would be 1.0215 atmospheres, okay? And you write that in your data collection page. Now we're going to vary the temperature by immersing that beaker in hot water, and I will have some hot water set up. This water is 38.8 centigrade water, okay? Or I'm sorry, yeah, 38.8 degrees C water. Now, I'm going to raise the temperature in my Erlenmeyer flask by immersing it in the hot water. Okay? And we should see an increase in pressure as that gas trapped air warms up in there. Okay? And you can see pressure's increasing. You should see a significant increase in the pressure. Okay? As it warms up. So wait till you see about the maximum pressure that you're going to achieve, 1.06. Wait for it to stabilize. So I'm going to call it 1.065 atmospheres. Okay? So that's your second data point. Put down the temperature of the hot water, which was 38.8 and 1.065 atmospheres. Okay? That's your second data point that you have. Now we're going to do another temperature bath. I have another beaker with ice water. So let's get the temperature of the ice water with the thermometer. Should be pretty close to 0 degrees C. And then you're going to put that temperature, once it stabilizes, in your data report. That's the temperature of the ice water. Then we're going to immerse this beaker now in the ice water. And we should see a significant decrease in the temperature. Okay, so I'm putting my beaker now in the ice water, and I'm going to hold it there because it's going to want to float up. You should see a significant decrease in temperature, or pressure, I'm sorry. If you do not see these pressure changes, then you probably have a leak in the system. So double check all of your connections. Okay, now we can see pressure's going down. It is now 0.98, 0.982, 981. Okay, so you're going to wait until that stabilizes at the lowest stable value. Okay, then put that pressure in your data collection page, and then you're also going to want to get that temperature from your thermometer at the same time. Right now it's reading, I would call that about 4.8 degrees centigrade. Okay, And that's all there is to the experimental part of this, this lab. Okay. Just be careful when you immerse the beaker, the 125 milliliter beaker, into your temperature baths to make sure that you see a significant change in pressure. If you don't see that, then you probably had a leak somewhere in the system. So I want you to double check all your connections and repeat that as you need. All right.